Welcome students. Today we will discuss about the sphere optimization problem. The objective function for sphere is given using first equation. For rastringe the second equation is given. So we have to solve the optimization for these two problems using grid search algorithm. So let us go directly. So you have to remember, you have to implement this function and this function, and you have to pass it to the grid search algorithm. Let us see. So first one is import statement. So this is where the grid function is defined. So you can see we are searching in the range of -5 to 5. You can also change the range. In between this range you can search the optimization problem. So let us write first the function here, and the first 5 types, step size defined, and then lower range, upper range, sphere function you have to write. So and minimization. So let us see the problem, the equation for sphere objective function. So it is a sum of xi squared. Let us implement. So you can implement like this. So I have already implemented, so I am directly copying. So you can use this function keyword and then the return sum of x to the power of 2. Here you have to remember that x is a vector of dimension d, okay, vector of dimension d, which you specify here, okay. So here for example we are taking dimension as 3, okay. So next we will define the step size, from where to where we have to search, okay. So first define the step size. It is also given in the form of a column vector. So here the step size is given as 1.1, 1.1, 1.1. So I am assuming the dimension as 3, okay. And the next thing is you have to define the lower range, from where you have to start the searching process. Say for example I want to start from 5.5, minus 5.5, 5.2, 5.2 I want to start the lower range, to the upper range is plus 5.2. So you define the upper range as a column vector in 3D vector. So here you can see this is for lower range vector and this is for upper range vector. So you can also change in between these two ranges. You want to find out the minimum optimization problem, okay. So let us see the output. So after passing all the things to the argument, the next thing is you have to compute the output. So let us see the first process. So let us save, let us select all these things. So you can see this at 0.3, 0.3, 0.3 you get the minimum value. Say for example you want to find out the maximization for the sphere function. So instead of min keyword you have to use maximization, okay. Let us run. So you can see this at minus 5.2, minus 5.2 and minus 5.2 you are getting the maximization value. So this is the minimum value you are getting for sphere function, this is the maximum value you are getting for sphere function in between minus 5.2 range to plus 5.2 range, okay. So the only thing is you have to specify the ranges, okay, in the form of a vector. This is a lower vector, lower range vector, this is upper range vector. Here I have taken the dimensionality as 3. You can also specify in different dimensions. So you have to implement the sphere function and specify the step size in the form of a column vector, lower range in the form of a column vector, upper range in the form of a column vector, and pass this to the your grid search algorithm and it will give you the output, okay. So you can see the output. So this is the minimum value you are getting for this sphere function, and this is the maximum value you are getting for this function. This maximum value you are getting at this solution. Okay, this maximum value you are getting at this solution. Similarly, this minimum value you are getting at this solution 0.3, 0.3, 0.3. So you have to understand like this. Thank you, students.